So we have Vulcan MO shortlist from 2022, and yeah, I'll start solving the first A1. Okay, and if the sounds terrible, please do let me know in the comments. I think there's a bit of a gap between what I say and what actually happens on stream, so do let me know if like the sound is like absolutely terrible. Um, Okay. Um, sure. So let's start with the first question. So we have some function f, uh, and then from R to R, and obviously we have the x, and then f. Wait, no, not f. Wait, I'll zoom in a bit. Okay. X times x. It's a bit glitchy for some reason. X plus, and then f of y. And that's equal to x plus y times f of x. Okay, so let's start with the obvious stuff. So if I plug in, for example, x equals 0, we will get the f of 0 is just y times f of 0, which could mean only one thing, that f of 0 is 0. Okay, I mean, now we can plug in x equals minus f of y. Oh, but I'll just move like this. Okay, yeah, and if I do like this, then I know that the motivation is behind I just want to make some f equal to 0, so the left hand side just becomes this, and it's equal to y minus f of y minus f of y times f of minus y, f of y. This. Okay. And obviously this thing is equal to 0, so either we get that y equals f of y, which would make us happy, or we also have a case that f of minus f of y is 0. Okay, well, we clearly know that unless f is equal to 0 at all points, which is a solution, we know that f is surjective just because if there's a non-zero solution, we plug in it into here and then just multiply this by whatever we want, which would essentially give us that this f is surjective, which means that this thing is surjective, and this would mean that essentially uh, either uh, either we have um, f of y equals y, um, or it's 0, I assume. Um, okay. Okay, so also if I plug in x equals 1, if I plug in x equals 1, I'll get the f of 1 plus f of y. That is equal to y plus 1 times f of 1. And this means that essentially, unless the thing is 1, and actually for any x, like it doesn't matter if I take any x, if there's a x that f of x is not equal to 0, I can actually say that uh, f is injective for all other y's because then these are equal and these are different if f of x is not equal to 0. So obviously the solution f equals 0 works. So this is a solution. And in the other case, if there exists a non-zero value, then we get that f is bijective. And from there, we essentially get that from here, we get that f of y would be equal to, well, minus f of y would be equal to 0, and so y equals 0. And therefore, we get that f of y equals y. And that's the solution for the first problem we have today. Oh, there's many comments. Yeah. Hey everyone. Hate missing you. Oh my. Okay. Yeah. I'm sure you can solve this. Okay. Let's go to the next question. Um, Merry Christmas to all the new people. I'll just take off my hat. And, okay. Moving on. A2. We have some weird inequality. Um, okay. So we do know that x1 is greater than equal to x2 is greater than equal to blah 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 blah. And we need to prove that x1 plus kx2 over this thing is essentially greater than equal to n times k plus 1 over 2. Okay, so let's have a think. Um, hmm, well, we know that k is greater than 1. So essentially what we can do is, I think, order all these things. So we know that x1 plus kx2, or actually, oh, we can't really do that. That's sad. I wanted to order them, and that would just like allow us to use some inequalities, the trans inequality in particular. Um, okay. Okay, so obviously, if like the equality case for this thing, I assume is when all of them are equal. Is it? Wait, is it? So if all of them are equal, if all xi are equal, then that would give us essentially k plus 1 over 2 and times, yeah, that works. So essentially, like, the equality case for us is pretty much no. Uh, and our job is just to show that it's the only case. Or, well, the only case where equality holds. So, yeah, I hate inequalities too. Stop mixing. Could you change the position? Oh, yeah, yeah, my bad, my bad. Um, okay, how about we do maybe like this? I'll just make my pretty face a bit smaller. I hope that helps. Um, okay, I'll try to keep it all on the right hand side. So, we have this weird inequality that we have to solve. And I mean, it looks like I would hope to induct on this. Just I need to decide what do I induct on. Um, so how about we induct on k? So k is greater than 1, right? Um, if I go from k to k plus, so let's just try some induction things. So if I go from k to k plus epsilon, right? Um, the left hand side increases by like epsilon just essentially cancels out, right? Well, okay, what we add is essentially epsilon and then x2 over x2 plus x3, and then plus epsilon x3 over x3 plus x4, and blah 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 blah, all this thing. Okay, and at the end we also get like epsilon x1 over x1 plus x2. We add this thing, And then we want to show that's greater than equal to, well, what we add here is essentially epsilon times n over 2. So we cancel the epsilon out. And we also see that we just want to show this is true. Um, yeah, like this. Greater than equal to n over 2. Mm, Well, this looks like the trans inequality, but it's a bit weird because we do have the xn over xn uh, plus x1. That's kind of weird. But yeah, it's weird that it also says k strictly greater than 1. Um, we for sure have to figure out how to do this thing nicely. Okay, so how about we try something like, okay, so let's start. So we go x1, then we have x1 plus x2 plus x2 over x2 plus x3 plus blah 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 plus xn over xn plus x1. How about we just throw in the 2 everywhere over here? Essentially, like, we know that every single thing here, except for the last one, is greater than 1 because just of this thing, of all these inequalities. So, okay, there's this, let's see. Let's, okay, getting xi and xa plus 1 closer should always make LHS smaller. That's a good idea, by the way. That's like solid. Okay. Could we just split x1 plus kx2 over x2 into x1 plus x2 over x2 plus x3? Yeah. We could do that. The issue is, uh, that this thing is like we can't really solve it with cyclic stuff because we do have a order in which it goes. So x1, then x2, then blah blah, blah then xn. Uh, and that's weird. The idea of like closing x1 and x2 is interesting. So I want to have a look at that. That's a cool idea, but let's just check that it works because I'm not sure it does. So x1 over k, wait, no, x1 plus kx2, okay, x1 plus kx2, x2 plus x3. So let's, for example, look at x1 and x2, right? The question is, oh, you close in the sum, I assume. But, or do you close in x1 plus kx2? That's another good question to ask. Um, okay, that's x1 here. Okay, x2 plus kx3, low key. I think that it's it's too complicated. So if you try to close in x1 plus x2, if this is fixed, then like everything just changes so weirdly that low key I think this doesn't really work. I just don't see it working. But maybe I'm wrong. Maybe my intuition is wrong. Okay, back to this thing. Like, I keep thinking about trans inequalities because, like, everything is a bit skewed, and this is usually a good indicator that they're useful. So, yeah, it's very weird. It's very, very weird. What else can we do? I mean, low key, by the way, we can, like, subtract. Uh, wait, I wanted to subtract, like, k plus 1 over 2 from everything. Will that give me something? Or not really? So then I'd get, like, an equality of greater than equal to 0. But I guess that's not the best thing. Or is it? Yeah, I think that's just weird. Yeah. Well, I mean, as I was saying, like, all these things are greater than 1. So the only problem is this hand over here. Because it's less than 1. And there's n of them. And that's the issue. Yeah, and for induction as well. I thought about that from the start. It's enough to show that the sum of x1. Yeah. Okay, I mean, we can try to show that by induction. Sure. Okay, so suppose this chunk is true. Now let's add, we want to add 2xn plus 1. Oh, come on. This goes to xn plus 1. This, like, the problem with inducting on this is that this changes the last denominator and also adds something else. So that's kind of weird. Like, the problem is it's cyclic, right? So x2, x3, like, they all go in x1 plus x2, then x2 plus x3, then xn plus x1. Then how would you resolve that you need to absolutely get rid of this thing and add something new? Do we just, like, try to bash it or something? I mean, I can try, but uh, just, I mean, I guess we can try. So if I start, I'll paste this thing again, just here somewhere. So I if I start for, like, n plus 1, so I go x1 plus k x2 over x2 plus x3 plus x2 plus k x3 over x3 plus x4. Also add xn. Wait, do I add xn plus x1? Yeah, I do. So let's wait. Yeah, x1 plus x2. Oh, a lot of things changed though. Are you sure that's a good idea? Thanks about Primo 1. Use induction on K. Well, yeah, I don't think induction on N works because, like, too many things change. But induction on K, like, K is greater than 1. So, I mean, it is logical that I think that for K equals 1, it seems true, but I'm not sure because, like, why is it K greater than 1? And the other thing is, like, we have nothing to start from. So that's another thing that's very weird to me. That, like, this thing shouldn't be true. So k is greater than 1. Like if k was 0, for example, the right-hand side would just be n over 2, and this thing will be the same as this. So it's, I don't think even this is true. So I think inducting in this question is like just death. Oh, that's the issue. But k is greater than 1 should be like used to uh set some inequalities. That's what I think. Because k being greater than 1, like I'm pretty sure that it must be used in terms of like kx2 is greater than x2, if that makes sense. Because otherwise that's just like you get these things that I don't think would have been true unless like the problem guy who wrote this question, this Ilya guy, unless he's like super weird. Like there's no reason why he should have um, said that k is greater than 1 if it's not true. So it's like kind of weird, I would say. So I would say that like we just have to focus on like just focusing on k is greater than 1. That's like the only lead we kind of have. Uh, so k is real, so we can't induct. We can by adding epsilon. That's the same as induction. So that's not completely right. So what I tried was like increasing epsilon a bit and still showing that the inequality holds. But as I said, the reason why it's not working. So if you look down here, so if you go from k to k plus epsilon, the reason why everything fails is because, well, I think it fails, is because we get this thing here, right here. 2x1 over x1 plus 2, blah, 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 blah. And this thing on top, if you plug in k equals 0, for example, that's just the same story. So the inequality would be true for all k and not just k greater than 1. So by that logic, I don't think induction works because induction is saying that one side increases more than the other side, and it's just like not working in this case. So, and k is greater than 1, since k is like a coefficient next to x2, for me, that is a clear indication that I think maybe what we can do is write k, instead of writing k, we write k, we just substitute with 1 plus k. I think that's maybe the correct thing to do, because if we do that, we cut off like this weird k is greater than 1 thing, and yeah, I mean, we kind of we kind of win the thing, if you understand this. But yeah, I'm not really sure. Yeah, so let's just do that. Okay, let's paste this annoying question again. Just try to finish it. So instead of k, we write, say, instead of k, I write 1 plus m. And then I say that the thing is equal to, we can then just factor the m out and say that it's equal to m, and then x2 over x2 plus x3 plus x2, no, x3 over x3 plus x4. And then I continue and I add essentially x1 over x1 plus x2. Okay, that's one part. That's factoring the m out. And then I just get the sum of x1 over x1 plus x2, like this kind of thing. Wait. Yeah, here I get x1. Wait, isn't it the same? Oh my gosh. Please don't tell me it's the same. Wait, what? Wait, did I do something wrong? I should have. I should have. Wait, x1 k equals 1 plus m. Okay, wait. mx2. So wait, this is mx2. Oh, yeah, yeah, it's x1. So this thing is not exactly that. It's x2 plus x3 and then x1 plus x2. I think it worked like this. So x2 plus x3 mx2. Yeah, yeah, yeah. Then we need to show that this is greater than equal to n times k plus 1 over 2. And now we use the k is greater than 1, so this thing is just n plus 2 over 2, like this. Okay, and this thing is equal to, I'll actually rewrite it as n plus mn over 2. I want it like that. And I think that one of the sides will be greater than n and the other will be greater than mn over 2. So probably this thing here is greater than n over 2, and this thing here is greater than n. And this looks pretty reasonable, low-key. So if I start with this thing, for example, this is just AMGM. So by AMGM, I know that like it's just a sum of like A1 over A2 plus A2 over A3 and plus blah 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 plus AN oops, over A1. And that is always greater than equal to N just because AMGM, right? Wait, that's yeah, yeah, that's correct. And now we just need to sort this thing out. And we need to remember that x1 is greater than x2 is greater than blah blah blah. Oh, we're done. Okay, fine. Oh, this is interesting. So this thing is, for example, greater than equal to x3 um, over x2 plus x3. Wait, is it correct? Is it correct? Yeah, and this thing is like greater than equal to x4 over x3 plus x4. And same with this thing here, it's greater than equal to x2 over x1 plus x2. Does that work? Oh no, that doesn't work because, for example, for xn, we get the opposite thing. So, like xn, when I look at xn over xn plus x1, this doesn't work. But what does work, okay, I think I figured it out. Okay, so if I delete all this, the cyclic stuff, like x2, x3, it's like unstable, so we don't want it. Like, we don't want any inequalities with them. The trick is to actually look at um, the denominators and say that this thing is greater than equal to x2 over 2x2. Yeah, okay. This thing is greater than equal to x3 over 2x3. So everything is 1/2. And this thing is greater than equal to um, x1 over 2x1. Yeah, I think that's, or is it? No, that doesn't work. Or does it? Let's see the comments. I just use Wolfram Alpha, bro. Yeah, of course. Uh, Bro, can you teach me trigonometry? I'm in high school. Yeah, of course, bro. Is making expression linear in terms of k useful? Oh, we're solving bulk move short list. So I mean, we again want this chungus to be greater than or equal to n over 2. Which, wait, isn't that the thing that I tried to start, like, to prove at the beginning, and we said that it's, like, cringe and shouldn't work? So yeah, I think it's like a fake solve or something. Wait. Mm, it's weird. Wait. Who created this question? Ah, yeah. It's this thing. Wait, I swear this thing is equivalent just to this thing is equivalent to this thing for 0. It's almost that thing. Oh well. Oh gosh. So um, okay, I think so. Let's rewrite again. So let's rewrite this whole thing just like more accurately. We get x1 is with x1 and x2. Then we have all these guys that are normal. So we have x2, and then we have x2 plus x3. And then blah blah blah. We have still the normal guy, xn minus 1, right? Over xn minus 1 plus xn. And then we have the weird guy, which is xn over xn plus x1. We want this greater than equal to. And we want this greater than equal to n over 2. So annoying. What is in the chat? Oh my god. This is so weird. Why why is this question so weird? Okay, this is not the same by the way as we had in the problem. Because if k equals 0, that's not the same thing. Okay, we want this thing, right? It's 2 x2 over x2 plus x3. All these things greater than or equal to n over 2. 'Or we want to show that, for example, x2 over x1 plus x2 plus x3 over x2 plus x3 plus blah 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 plus xn minus 1 over xn minus 1 plus xn. No, xn here. Xn. We want that to also x1 over xn plus x1. We want that to be less than equal to n over 2. Wait. Isn't there like a thing that... Uh, wait. Hmm. So all of these things, all of these guys are less than 1/2. That's pretty obvious. Well, the reason is because like the sum of these two is just n. So the sum of this is less than 1/2. So is this, and blah blah blah, until we get here, which is the weird part. Um, Less than equal to 1/2 to x1. Hmm. Okay, how about we use Cauchy-Schwarz, and from here um, we write that x1 plus x2 over x1 plus blah 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 plus xn plus x1 over xn should be... Wait, no, we can't... Wait, which word do I do it? Oh, I write from here actually. So I put x2 here and x1 here. Um, yeah, so I write from the second expression, from this one here, I write x2 here and x1 into here, and that should be greater than equal to 2n because of Cauchy-Schwarz. And now we cancel the first n and we just get x1 over x2 plus... Oh, finally. Oh, Jesus, bro, this is such a horrible question. Oh, my days, bro. Oh, my. Okay, and this is greater than equal to n, and we're done. Okay. This is just so trash. Okay. Okay, enough algebra for today, bro. I'm tired. Okay, the NT looks chungus as well, though. What is the smallest sum of digits? Okay, how about... Okay, guys, what do you want to do? Some, like, Combi, Geo, or, like, this chungus NT? Okay, IGCC is kind of hard for me, although it says basics. NT, fine. Bro, IGCSE is just, like, annoying as hell. Um, sure, so let's do that in some NT. But low key, uh, this just looks so chungus. Okay, let's read. What is this? Okay, I'm not solving this. I'm sorry. What is the smallest sum of digits? No, I'm not doing that. Um, A, B, N are positive integers. That A is greater than B, such that all of the following hold. These dividends, this dividend, this. Okay. For every natural number x, let P of x be the product of the digits of number x. Now, what is up with this NT section? Like, genuinely, what is wrong with this NT section? Speed 1. Okay, this is This is not the NT we like. Okay, let's do some geo. I need some rest from this trash algebra we just looked at. Maybe we'll look on another shortlist. Oh, wait. Given a cube? No, no, thank you. Uh, Consider a grid. Dionysius, red or blue. It is not that broken. It might come back to the C section. I don't want to see any more inequalities or Chungus functions because like genuinely it got me brain dead. So let's just like do some geo low key. Alright, okay. Let's just speed run the geo section, I guess. A couple of minutes. Just finish it up. Okay, I'll just paste the whole thing here. Yeah, and I won't be using GeoGebra because that's just gonna be too easy. So we're just gonna here. Okay. Let ABC be the Q triangle with CA not equal to CB. TATB be tangents to omega A and B respectively, which mean at X. Okay, let's start with G1. Okay. After that trash algebra, I do need a break with at least the G1. So I'm sorry, guys. I'll just zoom in. Okay. Check the comments. How much do I study maths every day? Um, well, like Loki, when I have nothing to do, if I finished all my schoolwork, I just do it for fun. It's like enjoyable. Okay, so let's start with the geo, I guess. So we have a triangle, CAB, I assume like this, which is like so weird. But okay, TA and TB be tangents to A and B respectively. Okay, so let's just draw this. And then what you need at X. X. And then let Y be the foot of perpendicular from the center O. So the segment CX. Okay, so it's the numpty point. Let's not be like weird, but okay. So we have a point Y here. Okay, what is up with the names? The line through C parallel to AB meets TA, so the tangent at A at some point Z, and show that the midpoint of YZ passes through the line YZ passes through the midpoint of AC. Okay, that's interesting by the way. I've never seen that. But it's very simple. Okay, so if I take the midpoint M of AC, I know that. Okay, I'll just zoom in for you guys. Okay, because this is just not it. So this is 90 here, and this is 90 here. So we know that CMYO is cyclic. But if I drop a perpendicular here and get a point N, here's 90 as well, and I know that MN is parallel to AB and it's parallel to like CZ, whatever that thing is. And wait, what? Wait, uh, this doesn't. Wait, did I read it right? BA or tangents at AB, yes. And then the line through C parallel to AB meets TA at Z. Prove that YZ pass through the midpoint. Right. Did I miss something? Because, okay, never mind. So we want to show that essentially Z, M, and Y lie on one line. Okay, and I say that by radical axis, I want to like do some PowerPoint stuff. So if I label this point T here, uh, CT, oh, ZC times ZT, Zm times Zy, and we have Za squared. Okay, this is harder than we thought. Okay, let's just Yeah, this diagram is trash, by the way. Let's just quickly come up with something. So if this angle is 180 minus gamma, right? Then we know that this 180. So we know that, like, if this is alpha, we essentially know that all these three angles are four, actually are all alpha. So 180 minus alpha, and we know that this is alpha. Okay. And so we also know that Z, C, Y, and A are cyclic, these four. And then I just need to show that, okay, so I know that these four are cyclic, this. And I need to show that Z and Y line one line. And essentially, okay, to show that like AZM is equal to this angle here, which is worse than, okay, so let's say which angles do I want to show that are good. Okay, maybe there's a cleaner way. Because like, okay, let's redraw the stuff without anything we don't need. Because we don't actually need point X. I don't know why they added it. Like, it's just weird. So let's just redraw a quick diagram and just finish this up. This taking way longer than I like to. So if I draw a parallel line here, tangent here, this is equal to this, midpoint here, and I want to show that if I take the circle here, which is tangent to the big one, I want to show that if I take a point on this median, so essentially such a point that this is cyclic, which we already showed. So it's like the way we define this point is such that this is cyclic. You got the point on these four. They're cyclic. We want to show that these line one line. And this is the point. Okay, we know that O is here, right? So we want to show that this angle here is the same as this angle here, which is equal to this angle here. And since this is the midpoint and this is midpoint, and this was 90 here, if I reflect it like this, it'll put on the circle here. And so we know that this thing is parallel to this thing, and we're done. Because this is equal to this. Alright, sweet. G1 finished. Now, G2. Let ABC will be a triangle. Finally, AB and AC are labeled correctly. And center I. Let's draw that real quick. Right, G2. So we have triangle ABC. A, B, C. We have in center I over here. Then we have internal bisector of angle BC intersects BC at point D. Okay, so we have point D here. And yeah, I'm doing it like shitty diagrams because GeoGebra would be too easy. And I just need like, and it'll take loads of time because like I'm a perfectionist. Okay, let M be the midpoint of the segment AD. Okay, sounds like something PowerPoint and like Apollonia circles, but whatever. And then F be the second intersection of MB with the circumcircle of triangle BIC. MB with PIC. Okay, here. Show that AF is perpendicular to FC. Oh, okay, let's redraw the diagram. So we have triangle here, ABC, like this. we have the incenter I, and low key, what I'll do, okay, B and C here. Now let's draw this line here and here. That's the point D. And here we have the midpoint M of side AD. And then we draw the circle BIC. This. Okay. It doesn't intersect it here. It does intersect it there though. So BIC like this. Does intersect later. BM intersects here at point F, and we want to show that AF equals AF is perpendicular to FC. Okay, and we know that M is the midpoint, so we obviously somehow have to use that. And that's all we have. Okay, so circle BIC. Look here, let's just invert at something. I would just invert at A probably, but or at I. If we invert at A, what do we get? BC, this goes to the thing. This goes twice. Okay, something weird. There must be a nice solution to also. Okay, so AFC. So how about we double AF? Okay. So if we double AF, we just want to show that AC equals CX, where this is point X, if we double AF. And then this is just parallel to this line. Wait, then how? Okay, so this now gets even weirder because I have to reflect A about B and then intersect like this. Okay, no. So let's just check the stream real quick. Are you Yakutian? No. What? Try out June 2022 1H. You from King's Mask? Yeah, I am. I remember that I have access to the Archimedean's account. Michael, how you doing, brother? Well, I'm good. How are you? How do you study math every day? Oh, no, how much do you? Wait, I answered that already. Okay. Did you find it? It's one of the pentagons. Okay. Um. Okay, I think I missed this Archimedean's guy. Going back to chat. Wow. I hope I didn't like straight up ignore him or something. I just didn't see any messages. Okay. AFC is 19. So how about we mark the midpoint here of AC? That seems reasonable. And we just want to show that AN equals NF equals NC. And we know that, for example, MN is parallel here. So that's, I guess, at least something. Oh, you're Maxime. Uh, Planov, I assume. Okay. Good, um, so I'm still thinking about this BIC circle because it doesn't make any sense. Okay. It doesn't really make any sense because F should lie in the circle, and the only thing we know about the circle is that, well, the angle is there is 90 plus alpha over 2. So maybe like something like this angle here is 19 minus alpha over 2. And then kind of wants, so if this is alpha here, we know that this is 19 minus alpha. So if I draw 90 degrees in here, I would get that these 4 points are cyclic, I guess. I don't think that helps me much though. So this would be like 90 minus alpha if this is 90. But I don't think that helps me much, Loki. And I just need to show then this angle is alpha, for example. So it would be tangent. So AFM would be tangent like AC, which is interesting. Mhm. All right, let's continue to log in. Let's log in for this one. This looks a bit harder than G2. So let's let's start log in. I here we have AI intersect here at D. Let's move it down. That is midpoint M. Here we have points such that these four are cyclic, and we want to like chase this angle over here. I'll just correct it a bit. Okay, and we want to show that this is 90. So let's think about what are things that we don't like about this. We don't like obviously point M, and we don't like point F, so we don't like absolutely everything. It's just the annoying part. This is an interesting idea. However, like in order for it to be something good and not just some trash, we would have to show that, like, for example, NW is perpendicular to FC or NW is parallel. Interesting, interesting. Oh, wait. Maybe F is like the Humpty point for this thing. Because we know that this angle here is 90 minus alpha. That's the only angle we know, or is it? Because surely, like, maybe BFD or AFB is tangent to this thing here, which could, like, help us a lot. Because, yeah, low key, this is 90 plus. So if this is alpha, this is 90 plus alpha, this is 90 minus alpha, and this should be alpha. And so if this is alpha, I know that this is alpha, so then we know that F is the Humpty point. Oh, okay, so our job is pretty understandable now. Let's say F is the Humpty point. We want to show of like ABD. We want to show BFIC is cyclic, and we want to show that AFC is 90 degrees. Okay, that seems much better. Oh, I'm so relieved, Loki. Okay, we know that MF times MB is MA squared and is MD squared. That's what we know. And okay, now it should be like very finishable. If I don't finish this, I'm like actually a piece of trash. So okay, if I connect this, we know that this is Humpty point. So okay, let's chase some angles. We have I here. So I is related to this angle here. And okay, I do know this angle, this 180 minus 2 beta. It's 90 plus beta. Nothing really interesting here. But probably instead of going for I, we should go for W because it looks like a bit more perspective there. I would say. So let's draw the circle. Whoops, like this. I know it's a bad circle, but it is what it is. Okay, let's draw W here. And then essentially we know that WB is the tangent to the circle ABD, and this is the Humpty point. So we know that the Humpty point lies on the Apollonian circle of ABD. I is the, okay, and so does I, and W is the center, so we're done. Voila. Okay, for BFIC our site. We showed that. And now we just want to show that AFC is 90 degrees. Uh, well, AFC is 90 degrees because angle chasing, I guess. Let's just chase them up real quick. This angle is alpha. This angle then is alpha. This is alpha. This is 90 minus alpha, and we're done. Okay, this is a nice question. Okay, right. Read the chat real quick, and we'll continue with G3. Okay. What major are you, or still in school? Yeah, I'm still in school, bro. Hi, what problems were suggested for solving? We were doing bulk and MO, so we just did some algebra question. We did A1 pretty quickly, and then we stuck on A2, which was like very chungus and annoying. And then I tried to look at the NT section, it was even more annoying. So I just like started spamming geo questions. Uh, bro, if you want an easy question, June, I'm locked in. Guys, who to get into IMO? I don't know. Okay, G3, ABC, a triangle, and let omega be the circumcircle. Just paste it in on the side. So think about like bulk and shortlist as well. Like the hardness and the difficulty of the questions are like so unpredictable. Like G2s can be very easy, but can be like also very hard. It's just so annoying. But okay, right. So wait, let's power up, and you know I'll get my Christmas spirit. Right. There's also another solution using inversion. Yeah, bro. Probably. I mean, I think mine is a bit more technical, which is not good or bad. It's just how it is. Okay. ABC and omega is in circumcircle. Let's start with that. BC. Omega is the circumcircle. E is the midpoint of my. Oh my days. No way. They marked E as the midpoint of the minor arc. That is absolutely like crime against humanity, I guess. Okay, M is the midpoint of BC. Yo, I mean, after E is the midpoint, I don't expect anything from this question. Let me be the other point of intersection of AM with omega. Jesus, bro. And bro, I know that it's like some guy from Vietnam like that created this question probably, because I swear uh, no one else actually like names these points like that. Okay. We have V here, and uh, F is the point of intersection of AE and BC. So it's just the bisector. Again, like I'm saying, wait, who's the writer of this question? Did they write it in the post? Oh no, they didn't. Okay. Uh, X is the other point of the intersection of the circumcircle FEM with omega. Okay, so let's not draw the circle and just be patient, I guess. But we know that it's like this point here, X. Its prime is the reflection of V with respect to M. Oh my gosh. And A prime is the foot of perpendicular from A to BC. Yeah, this is a problem for Vietnam. I can feel it. S is the other point of intersection of XA prime with omega. Oh my. And Z is on omega such that AX equals AZ. Show that SX prime and Z are clear. Yeah, that's Raps. Okay, I mean, FMEX are collinear. Well, they're cyclic, so I know that if I draw ME like this, and I take the midpoint of the arc here, and then I know that these points line one line. That's pretty this. The reason is just PowerPoint N to BC, arc community lemma, blah blah blah. Okay, that's the boring part. What else? Well, I also know uh, that x is actually the reflection of the Humpty. So x prime is obviously the Humpty point because it's on the median, and bx prime c is 180 minus alpha. Uh, and I also know that x, it lies on the Apollonius circle of BC because XF is the bisector of BXC. So that's the reason why uh, it's like the reflection of x and x prime, why x prime is named like that, which is like weird, but whatever. And so, for example, F is the foot of the bisectors, so we know that A, x prime, F, and x lie in one circle. But x is the reflection of the Humpty point, so A, B, x, C is harmonic. And then if I draw x, A prime, I intersect it at S, and we want to show that S Humpty point, and then AX equals AZ. So essentially, I want to show that AS is the external bisector of angle x prime SX. So after all these like 10,000 points, the only thing that like the author wants us to show, and like I'm willing to put everything on the line that this is a problem from Vietnam. Like I just sense it. Like, cause I've seen a lot of like weird Vietnamese questions with like thousands of points, and I just feel that that's the vibe here. Okay, A, B, C. We have the Humpty point, X. We have the reflection of the Humpty point, X prime. And we have the foot of the perpendicular from A, intersection like this, S. And we want to show that AS is the external bisector of X, S, X prime. Okay. I was literally putting this all around. I mean, that's like, I'm not putting anything on the line because I know I will do it. So there's not much to gamble. Uh, so what I'm solving, and x prime's the Humpty point. Yeah, that's right. Okay, this is Balkan, by the way. Just let you know. So, alright. We want to show that AS is the external bisector of x prime SX. That's the whole question. Now, we obviously want to focus and target point S because we understand what point x prime is. And the way we do that is if I intersect here, point N, I will get that if, since AB x prime C is harmonic, I project it through the foot of the height and I get that S, B, and C is harmonic. And this essentially means the reflection of N about BC will be the Humpty point of SBC, which means that it's the Q point. It's here. S is the Q point because H is the Humpty point for SBC. And now we just want to show again. So S is the Q point, and therefore we know that MSA is 90 degrees. So we just want to show that SM is the angle bisector of x prime SX, but we know that SX, X prime are cyclic. Why is that true? Well, it should be, but I'm just trying to see why. what's the quickest way to show that they're cyclic? Okay, I mean, this is equal to this. Okay, this is a bit harder than expected, but once we show that, we know that xm equals x prime m. And from there, we're pretty much set because if Sx x prime are cyclic and these are equal, then SH is the bisector, SA is the external bisector, and we would be done. But we just want to show that Sx x prime is cyclic. So easy. Why am I bugging? Uh, I'm bugging so hard. It should be like obvious, by the way. Like, I just feel that it's obvious, but I don't see it until the end. I mean, okay. This is 90 and this is 90 here as well, right? So this is, so ASXH cyclic. So this angle here is equal to this angle here, and this angle here is equal to this angle here because of parallel, and this angle here is this angle here, so we're done. Okay, yeah, like it's expected that the harder the questions, like for Balkan, it's quite a common theme that the deeper you go into the shortlist, the easier the question is. But this is just like, this shouldn't be in the shortlist. It's just like a bunch of facts jumbled into one question. So I'm against such stuff. I like G2 though. Okay. Uh, let ABC be a triangle. Okay. Let's do this one and then just do some NT. Maybe not from Balkan shortlist though, because the questions from Balkan NT section, this shortlist section, it's just trash. Okay, I'll read the chat real quick. Uh, did any of y'all participate in that competitions? Yeah, I did participate in BMO. Uh, the BMO was like harder than usual, so yeah, Merry Christmas, Dennis Prince. He's making it to BMO2 medal or the camp for selection of IMO team within a year after getting BMO1 distinction doable. Yeah, for sure. It's just the practice thing. Like it's not based of like any skill. It's just like how dedicated are you. And if you are close to BMO2, that's like already a good level. The only thing is just like practice and obviously listening to me and putting likes on all my videos and subscribing, because if you do that, everything is going to be fine. What should I do to enter BMO? I think you have to live in UK. That's the first thing. That's the first prerequisite, and then you have to do well in SMC. Yeah. I, let ABC be a triangle. Let the tangent at B to its circumcircle meet the internal bisector of angle A at P. Okay, let's start. So we have the circle, and yeah, the diagrams are bad, and we're like sometimes solving with bad diagrams helps you to like practice your intuition, even on bad diagrams, which is a good thing. But in retrospect, do try to make your diagrams as good as you can, because like it actually makes a big difference. It really does. Okay. Um. Oh, we hit 1.54K. subscribers. Thank you, everyone. But okay. Let ABC be a triangle. Let tangent to B to its circumcircle meet the internal bisector of angle A at P. So you have internal bisector, you have tangent. Oops, that's the tangent. And by the way, like another good thing to do is to practice like drawing diagrams without uh, without ruler or compass. That's like a very good practice thing to do. And like to to be honest with you, I never use a compass or a ruler. Never. I just don't feel like it. Okay. The line through P, through that point, parallel to AC, meets AB at Q. So we have some weird stuff. So here meets at point Q. And assume Q lies on the interior segment A. Yeah. Uh, can they just... Mhm. Yeah. I'm not trying to like be annoying, but I'm not gonna read for 1,000 of seconds. So I mean, I think we solved enough geology, and I think that nothing. Wait, let me read this. D is the other intersection of angle bisector. Let E and F points on AB such that A equals AF, and let the point P of intersection of AD and EF. Let M be the midpoint of BC. Prove that AM and the circumcircles of AEF and PMD. Okay, this looks interesting, but it might take a while, or it's probably easy. Okay, how about we do some NT? Okay, low key, very low key. Because I'm starving for some number theory. Okay, this, I'm not doing that. Uh, yeah, this section was the bad NT section. Ooh, 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 this looks interesting. 2021 patrol. Okay, see that in section. Can every rational number q be written as I? Okay. Yep. Yep. Okay. Okay. No thank. Maybe we should go to like some different contests because Vulcan NT sections are just not. Okay. What do we want to do? Oh, Romanian Masters of Mathematics. This. Okay, shortlist. I think I've done this one. What's the ends here? This might take a while. All of them might take a while, but let's just see which looks. Okay, I think this is just not rational because RMM will take ages. How about IMO shortlist? IMO shortlist should be very doable. Wait, I skipped it. Do the EMC question. Oh, sure. Let's just do the EMC. Oh, sure. Well, I mean, I have to European maths 25. Alright, let's see. Problems. Senior. You're a senior. This looks interesting. This looks. Okay, what is this NT? Oh no, this is algebra. And this is NT. Oh no. First NT is just a waste of time. How about Junior? I want some interesting NT though. Okay, let's try this. I mean, I'm not sure I'm going to solve this, but try. Uh, okay, let's try to tried to do this last time too, and it's kind of sad that. Uh, I'll try this, but I can't promise you that I'll solve this because it's IP4. Find positive integers n with the following property. For every positive integer b which divides n, there exists a positive integer k which divides n such that d plus n divides dn plus k. Okay, let's rewrite this. I'll check the comments one more time before I start looking. Jesus, I do believe he died. Yeah. Yeah, God bless you too. God bless you too. Uh, at least in the international stage, IMO, a lot of it is talent. Um, I wouldn't agree, low-key. Like, a lot of it, like, I think that getting good at IMO is just like a lot of practice and just believing in yourself and not giving up. Like, if you just solve enough questions, like, there's no way you don't get into IMO. So, it's just a time issue. Like, that's what I would say. Okay. Find all positive integers n with the following property. For every positive integer d which divides n, so for any d that divides n, there exists a positive integer k which divides n, such that d plus n divides dn plus k. Okay. Okay, sure. So for every d that divides n, there's a k that divides n, such that d plus n divides dn plus k. Holy. Okay. I mean, so if d is equal to 1, then n plus 1 divides n plus k. And yeah, that's fine. So how about let's just test the waters and let's just test some n values. So like I know it's a lazy approach and you want me to solve it from the spot, but low-key, right now I'm feeling like just exploring the waters. So 1, 2, so that's the values of n. 3, 4, 5, 6. Okay, please don't make the 6, 7 jokes, please. I beg. I beg. Okay. So 1. So d plus n, d is 1, 1 plus 1, yeah, checks out. 2. So 1 plus 2, well, we showed that 1 always works, right? So let's start with d equals n, for example. 2n divides n squared plus k. That's what we want to show. We're doing this for n equals 2. So, and in this case, wait, I don't think it's, wait, what? For every positive integer d which divides n, so for example, d equals n, 2n divides n squared plus k. So, yeah, so for n equals 2, this is impossible, right? So, because 4 divides 4 plus, oh no, is it? Wait, yeah, it's impossible. Okay, 2 gets out. Okay, how about 3? 6 should divide 9 plus k, which essentially means k equals 3, which works, and 1 works always. So 3 works, right? Uh, yeah, 3 works. So let's look at primes, for example. So 2p divides p squared plus k. The only the only possible way is k equals p. So like all primes except for 2 work. So 5 works, 7 works, 11 works. They're right, 13. 13 works as well. Okay, how about 4? N equals 4. D equals 1 works. D equals 4. We get 8 divides 16 plus k. And yeah, that's wraps. Okay, there it goes. So for example, if n is divisible by 2, so if n is divisible by 2, so for example, n is divisible by 2, and suppose n is equal to 2 to the power of alpha times some odd number k, then we know that 2 to the power of alpha plus 1, k, oh, we get a repetitive k, but let's just call it k prime. That divides 2 to the power of 2 alpha, k prime squared plus k. This divides to alpha plus 1 to alpha plus 1, so this should be at least to alpha plus 1 plus something. And yeah, this divides k prime, and this should be divisible by k prime. So this should be 2 alpha plus 1 k prime. And yeah, unlucky. Okay, I did everything right, right? 2 alpha plus 1, 2 alpha. So all the even ones, they're just chunguses. Okay, so all the evens won't get out. I assume I didn't make a mistake here. Uh, yeah, I swear that's how it works. All the even ones get out. Yeah, I think that's right. Yeah, let's read the chat real quick. Guys, give me a question I want to try solving. Proof from its Jimmy, how does one get good at math if you're like G10? If you're G10 like me, do y'all self-study? Grade 10 or something. Yeah, self-study, bro. Like a lot of people do. That's for sure doesn't mean that if you don't have anything, then you can't like get anywhere. Like for sure, it is a possible way for you to get good. Because I know personally a lot of people that did that. During the contest, I proved the primes work and didn't write it down on the official paper. Hmm. I'm not sure about the answer yet. I assume primes work, but yeah, well, they do clearly. All primes except two, and also one. One works as well. All the even ones don't work. We already showed that. Yeah. So now, for example, let's test nine. So nine is the first. So nine will like actually give us some information because it's like an odd integer that's also not prime. So for odd ones, when 2n should divide, n squared plus k, and take k equals n, and then just get 2n divides n squared plus n. And that will be true because n plus 1 is divisible by 2. So 1 and n are good to go. So the only interesting thing is like 3, for example, for 9. That's the only interesting thing to check 3. So 6 should divide, wait, so d plus n, so 9 plus 3, so 12, should divide d times n, so 3 plus 9, 3 times 9, 27, plus k. And k divides 9. So k equals 3 doesn't work, k equals 9 works. So yeah, not only primes work, this k equals 9 works for sure. And if I look at, for example, p like prime to the power of 2, so p squared, if if n is equal to p squared, we can say that 2p squared should divide, oops, squared. Okay, I'm looking at this, so it kind of confused me. So let's just rewrite d plus n divides dn plus k. if I look at p squared, p squared plus p minus p squared d is p should divide p cubed plus k. And yeah, as we see, k equals p squared works perfectly. So that's great. So that's great. Okay. Yeah, I think that works well. So how about n equals p cubed? So wait, p to the power of alpha, let's just quickly get that out of the way. So d will be then p to the power of some k, or let's say t, p to the power of t plus p to the power of alpha, where this is n, should divide p to the power of alpha plus t, which is the product, plus some k. And if I take k equals p to the power of, wait, dum, 2t or 2 alpha, wait, 2t or 2 alpha, oh. So yeah, if n equals p to the power of alpha, for example, if I take, okay, wait, so it's not always possible, right? P to the power of 2 alpha or p to the power of, so I know that t is less than equal to alpha, and k is also like p to the power of m, where m is also less than alpha. But then, for this to be true, wait, if t is, for example, alpha minus 1, right? Surely it's impossible then, if alpha is greater than 2. So t equals alpha minus 1. So so maybe the answer is like, I don't know. Okay, let's not skip to that part. P alpha minus 1 plus p to the power of alpha. And that should divide uh, p to the power of alpha plus t, so p to the power of 2 alpha minus 1 plus p to some power of m. So if I multiply this by p to the power of alpha minus 1, then I can cancel this out and subtract p to the power of 2 alpha minus 2. Yeah, 2 alpha minus 2. And p to the power of m is less than that. So I think, wait, p plus 1 must divide this. So this is minus 1. This is 1. Oh my gosh. Why did it have to be so annoying? The n plus d divides n d plus k. What if d is equal to n over some prime p? Then I know that n plus n over p divides n squared over p plus k. So this thing is divisible by n over p. This thing is divisible by n over p, so k must be divisible by n over p. And if I take the p as my smallest prime, so p is the smallest prime that divides n, then I know that k is divisible by n over p, which means that k is equal to something like some number r times n over p. And I know that this should divide n, which means that r over p isn't like, well, r is clearly less than p then, less than equal to than p. And also r should divide n clearly, because or r is equal to p. And since p was the smallest factor of n, then I know that r is equal to p or r is equal to 1. So for the smallest prime p, I know that either n plus n over p must divide n squared over p plus, so first case scenario is r equals p. So k is just n, right? So this is just n. In this case, is that true? Let's check. I mean, if I take away, I get this, and then I take away this, and I get squared minus n over p. That's just n times n minus 1 over p. This divisible by n over p, this divisible by n over p. So let's divide everything by n over p. You'll get n minus 1 is divisible by 1 plus p. So yeah, p plus n is divisible by p plus 1. But we knew that p was the smallest factor of n, and p therefore divides p plus n. Which means that so, there's a q that divides p plus 1 and divides p plus n. Again, n plus p. N was pk. So know that p plus 1 divides p plus pk. So p plus 1 divides k plus 1. Which makes sense. There's nothing wrong with this, I assume. Yeah, there's nothing wrong with this. Okay. That's unfortunate. And what about r equals 1? So that will give us k equals n over p, which essentially gives us this thing. And then if I divide by n over p, I get p plus 1 divides n plus 1. I get p plus 1 divides n plus 1 here, and I get p plus 1 divides n minus 1 here in this case. Okay. Okay. Which is, I mean, kind of limits what n can be. I mean, right? Wait, n over p, n over p. Yeah, I think that's right. I mean, we can also try to set if n is equal to p to the power of alpha k, and k is not divisible by p, where p is the smallest prime, then we know that n plus n over p to the power of alpha should divide the product, which is n squared over p alpha plus k. So this divisible by n over p alpha, this divisible by n over p alpha, so k is divisible by n over p alpha. So I mean, yeah, k would be equal to something like Rn p alpha, and k should divide n, so R should be like power of p, and mm, and I mean we can cancel by n over p to the power of alpha, get p to the power of alpha plus 1 should divide n plus this r, where r is a power of p, so p to the power of some beta, and this thing is p to the power of alpha k. Beta is less than equal to alpha, so we can do this. P to the power of alpha plus 1 divides p to the power of alpha minus beta k plus 1. We can like subtract and divide, and, like I swear this has like okay, yeah. I think there's a thing that like this thing has almost like zero solutions because p to the power of alpha, we know that plus 1 should divide p to the power of alpha minus beta k like minus p to the power of alpha, and here it goes p to the power of alpha plus 1 divides k plus 1 here. Oh, it's like plus 1 divides k minus p to the power of beta. K is some factor of n. Wait, k is a factor of n that's not divisible by p, but beta is less than equal to alpha, and so like k should be like greater than p to the power of beta, or at least 2 times p to the power of beta for this to be true. This is just a headache. This is just a headache. So essentially, like for any alpha, wait, no, not for any alpha. Okay. Okay. Let's. So what I thought here, we used it for n over p, but we didn't use for p. So we also know that n plus p should divide np plus some k. And I can divide everything by p and say that n over p plus 1 should divide this thing here. Um, k plus 1, wait, k plus 1, and we showed that p plus 1 divides n plus 1, or p plus 1 divides n minus 1. We showed one of this. If p plus 1 divides n minus 1, then p plus 1 divides p plus n, and we would get that p plus 1 divides np plus k, which is equivalent to p plus 1 dividing n minus k. Then p plus 1 should divide k. P plus 1 should divide k, which means that there's and k divides n, which means that there was a factor less than p, which is prime, because p is not equal to 2, so p plus 1 is not prime, that divides n, which is a contradiction. So this case of p plus 1 dividing n minus 1 is just impossible. So the only case we have is p plus 1, the smallest factor, must divide n plus 1. And besides that, we know that n plus p must divide np plus some factor plus k. Okay. P plus 1 doesn't divide n plus p anymore, which is an issue because we kind of wanted that to help us. We really, but on the other hand, we do know that then in this case, uh, r is exactly equal to, so n plus n over p should divide, yeah, so this case, n plus n over p divides n squared over p plus n over p. So we know that p plus 1, yeah, that's essentially the same thing. Plus 1 divides n plus 1. N plus p divides np. Okay. This is getting depressing. Okay, n over p plus 1 divides n plus k over p. Yeah, the issue is now that n plus p doesn't divide thing, but n minus p does. So n minus p does divide this thing. So I want to find, like, from this expression, n plus d divides dn plus k. I want to find such a d that this thing divides p plus 1. So p plus 1 divides n plus d. Well, d equals 1 would be nice, but it doesn't really work. Does it? D equals 1. I mean, d equals 1, we already checked it. Doesn't really work. Hmm. So if at least we got that kind of that if n is p to the power of alpha times some number k, where p is the smallest prime, g plus 1 divides n plus 1. Okay, amazing. That's just from plugging it in. I mean, we can try n over p squared, but we kind of have to get into this. Let's read the chat real quick. Mike, how long have you been doing this? Doing what? Mm, what is it about? Blah, blah, blah. I've never heard of what's Gal Cow, by the way. Um, hardest competition is RMM though. But yeah. Okay. P. Let's continue thinking, I guess. So n plus d divides dn plus k. T plus 1 must divide n plus 1. Mm, we used 1, we used n. Mm, Okay, well, let's make one clear. This is divisible by d, this is divisible by d. So instead of k, we can write always dk. And we can write, therefore, let's write n as equal to bd. Then we can write ab plus 1 divides abd. And k will be like 80. So this. From here, we can get ab plus 1. So k equals ab. This k is divisible by d. So ab plus 1, therefore, is dividing abd plus d. So ab plus 1 divides a minus d. Or any d I choose. Which means that, for example, when I chose d as being the smallest and not 1, this essentially gave me that ab plus 1. Well, it gave me that ab plus 1 is, well, the difference between these two. Like a is equal to d, I assume. That's what I got. Or a is equal to 1. Yeah. And a is equal to 1 would give us b plus 1 divides d. So when I chose d is equal to p, I got d equals p. I got ab plus 1 divides a minus p. Where a, for example, if it's p, so a is either p but then that's so a is equal to p, which would mean that n is divisible by p squared, or a equals 1, which give us b plus 1 divides b plus 1 divides p minus 1, which is impossible. Or, yeah, impossible. Unless b is equal to 1, but then n is prime. Then we have greater, and then that's just impossible. So a equals p or a equals 1 from here. So a equals 1, p minus 1, b plus 1 divides p minus 1. Yeah, we said that that's impossible unless b is equal to 1, which is prime. So a equals p. So that's what we got. So we got that n is equal to p squared times, and also we got that p plus 1 divides n plus 1. That's what we got as well. So this thing is congruent to b mod p plus 1. So p plus 1 divides b plus 1 as well. So okay, if n is equal to p squared b, well, let's take, okay, we took d equals pb, right? And that's how we got p plus 1 divides b plus 1. So if I take d equals pb, I get p squared b plus pb divides the product, which is p cubed b squared, plus some number k. And then we say k should be divisible by pb, so k is divisible by pb, which means that either k is p squared b, or k is equal to p squared, or just pb, because p is the smallest factor. So, and if k, yeah, that's essentially what we got, and here we show that, like, k, so actually this one, so k is not equal to n. So k is not, we show that k is not this one, we show that k equals pb, and from here we get p squared b and p plus 1. And now we can officially rewrite this as p plus 1 divides p plus 1. Or p plus 1 divides b minus p, thus splitting her. Okay, so we get this. So p plus 1 divides b plus 1, and b plus 1 divides what's, and also, yeah, divides plus 1. Okay, now let's try taking d equals p squared, for example, and then, or d equals b. So if I try d equals b, I get b plus bp squared divides b squared p squared plus number k, and k divides p squared b. k is divisible by b, so k is equal to like kb. So k divides p squared. Now I can cancel the b out and get 1 plus p squared divides bp squared plus k. Now that's the same as 1 plus p squared divides k minus b, or shall I say b minus k? I know k divides p squared. K is, yeah, so I know k divides p squared. So if k was, for example, p, so yeah, this, b minus k. So either b minus p, b minus p squared, or b minus 1. Okay, let's just look at d equals b squared now. I think we can go much further. P squared plus bp squared should divide the product, which is p to the power 4b plus some number k, which should be divisible by p squared, so it's p squared t, and t should divide b. So let's write that b equals t times some integer u, and now we divide by, or wait, I don't even have to do that. P squared, we divide by p squared, and we get 1 plus tu divides p squared tu plus t. And so 1 plus tu divides p squared u plus 1. So now we divide by, we like this thing, p squared u minus ut, and cancel the u out. So we get this, p squared minus t. And now we know that t divides b. 1 plus, so tu is just 1 plus b. It's just 1 plus b. Divides some p squared minus t, or t divides b. And as we see, p squared is much less than b, or this thing like here wouldn't be true. So yeah, 1 plus b, when it divides, if this is positive, p squared minus t, if this is positive, we know that b is greater than p squared, unless it's like p squared q. So that's like separate case. If it's less than 0, p squared minus t, if it's less than 0, then it's less than t, and t is less than b, so there's absolutely no cases. And or t then must be equal to p squared, and that's the only case. Then v must be divisible by p squared. V must be divisible by p squared. V must be divisible by. So v then is like u p squared, right? From this thing. So like, I mean, we get that n is like p to the power 4u, and then p plus 1 must divide b plus 1. So p plus 1 divides u plus 1. And it kind of goes like a dropper because we went from n to b to u, blah, 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 blah. And at some point, we will stop. And this point is where probably like u is equal to p, right? Because we went from n to b to u, and it's the same process how we get it. Yeah. And then if we also look at here, can we maybe like tidy it up? 1 plus p squared. So we knew that b divides p squared, so it's p squared u minus either 1 or p squared. It can't be p or p squared. Can be. Because then see, like u minus 1 divides, okay, pu minus 1 divides that. Is u less than p? Probably no, but yeah, it's like, this like, doesn't give us much. But yeah, it does go like a dropper, so we went from p plus 1 divides n plus 1 to p plus 1 divides b plus 1 to b plus 1 divides u plus 1. And we always can induct on that. And essentially, we went n equals p squared b. Then from there, we went to p to the power of 4. Well, p squared and p squared u, right? And from there, we go on until there's no p squared left, which would give us essentially powers of p to an even degree, right? That's that's the whole thing. Because wait, 9 worked, right? What about 27? Let's just check that 27 works or doesn't work. So n equals 27. Maybe all powers of p, because either we can stop here, either u equals p also works. So I think it's powers of primes that work. So let's just check 27 of all primes as well. So d equals 1 works, d equals 3. 3 plus 1 divides n plus 1, and d equals 9. So here it's like 3 plus 27 should divide 81 plus 9. And then for d equals 9, we get 9 plus 27 should divide 2, 4, 3. Here we have 36. 36, 36 plus a factor of 27. Okay, so 180 divides 36 and 216, then 2, 5, 2, and this is plus 9. So all powers of prime would work because of this algorithm here. Yeah, so u equals p works, and u equals setting u as 1 also will just work, I think. Wait, p plus 1 divides p squared plus 1. Okay, but I mean, we showed that in the end of the day, the end of the day, it's a power of prime, for sure. Wait, or did I mess up here? Or did I mess up? I don't. So it's either this, because we always slide in out a 2, or it's just p squared q. P squared q, it's just, so it's either a power of p, which we showed that, we'll show later that works, either this, and for this case, we just want p squared q plus q, for example, to divide p squared q squared. So p is less than q. Plus some factor, k. It should be divisible by q, so let's just say q times r. Divide this all by q, get p squared plus 1. Divides p squared q squared. That's q times r, where r is 1p over p squared. Divide this thing by q, get p squared plus 1. Divides p squared q, p squared plus, yeah, q plus r. So r can't be q. It's not divisible by q squared. So, and yeah, and we know that this thing is equivalent to q minus r. And q minus 1 is not divisible by p. So q minus 1 divisible by p squared plus 1. That's a case. But other than that, I think, or q minus p is divisible by p squared plus 1. But I think this, yeah, I mean, p squared plus 1 divisible by q minus 1. That means q is a lot bigger. That's fine. I mean, I hope that there was a nice finish to this case, but I'll just try it, just in case. I like a good case bash. P squared q, pq maybe, and it must divide p cubed, oops, q squared, plus some k. Divide this all by pq, and get p plus 1, must divide the pq p squared q, right, pq pq, plus some k prime. And since k prime divided k divided p q squared, it's like either 1 or p. We can rewrite this thing as just q plus 1. So it's either 2q divides p plus 1, which is impossible, because q must divide p plus 1. Oh, wait. Oh, gosh. So q plus 1 divides p plus 1, right? Oh my gosh. Or q divides, so p plus 1 divides 2q. But then p plus 1 is divisible by 2, so it must be equal to 2q. So p plus 1 is equal to 2q. But if p plus 1 is equal to 2q, this is just not true. So contradiction. And also q is smaller. So p plus 1 must divide q plus 1. So we also know. Uh, then, mm, then we know that q plus p squared, I think, must divide both p plus 1 and uh, p squared plus 1, which are like coprime excluding 2. But this is like v2 of this is like at most 2. So like we can safely say like the product of this times the product of this over 2. Let's divide this. And this is like essentially almost p cubed over 2. And this is q plus p squared, which means that q is like greater than p cubed. Okay, this doesn't really. Okay, q minus 1 divides p squared plus 1. P plus 1 divides q plus 1. Okay, this doesn't give me a bound that I wanted on q. Yeah, I need. Yeah, that's not what I need. Okay, this doesn't. So p plus 1 divides q plus 1. And p squared plus 1 divides q minus 1. So, yeah, this won't give me much. But we have one more thing to try. It's just plugging in p and p squared. So I know that p squared plus p squared q divides p to the power of 4 q plus k. K must be divisible by p squared. So it's either p squared q or p squared. So p squared here. Just cancel the p squared out to here. Cancel this, cancel this. So you get q plus 1 divides p squared q. So it's just minus p squared plus k. Okay, and now I think we get what we want. Because we have q minus 1 dividing p squared. So q minus, no, being divisible by p squared plus 1. And q plus 1 being divisible by k minus p squared, where k is what? It's like 1 or q. And as we see from this thing here, q plus 1 can't divide p squared plus 1 because of inequalities, and uh, q plus 1 also can't, if q plus 1 divides p squared plus q, then we just subtract, like we get minus 1 here, and get q plus 1 divides p squared minus 1, and q minus 1 is divisible by p squared plus 1, so contradiction by inequalities. And so yeah, this case is also always possible, so just by induction we like go down and down and down, and so the only possible answer is primes to the power of alpha, which we just want to check. Does that work? And odd primes. Oops. Odd p. Oh gosh, this okay, I mean at least we solved it. Um we just need to go uh p to the power of beta plus p to, let's say this is just p alpha to beta like this. So this is p alpha plus beta. And this must divide p to the power of 2 beta plus alpha plus some factor k. This should be true. So this shouldn't be divisible. K should be like of the form p to the power of beta plus m for some m. That's what we're essentially searching for. We can divide by p to the power of, so m should be less than or equal to alpha. So we can divide by p to the power of beta and get 1 plus p to the power of alpha. Should be dividing p to the power of alpha plus b plus p to the power of m. Okay, m is less than or equal to alpha, so we get 1 plus p over alpha. Should divide p to the power of alpha plus beta minus m plus 1. And if I said m is equal to beta, we get the desired thing, so we're happy. Okay, this was an interesting solve. I mean, yeah, it was pretty hard. But yeah, thank you everyone for watching, for joining in. Um, and yeah, I think the stream is coming to an end. So thank you everyone for joining in. Thank you for all the support. Merry Christmas, everyone, and bye bye.